we'll jump in with the first problem. So it says a bacteria population is growing exponentially with a growth factor of 1.5 each hour. By what growth factor does the population change each quarter hour? Select all that apply. So when we start talking about fractional changes, it's good to think about how many times it's changing within the 1 hour. So since it's a quarter of an hour, if I think about having a table, here's my input, here's my output. I don't really care what these values are, but I know that this change is going to be times 1.5. If I wanted to find the change in a quarter of an hour, so from like 1 hour to 1.25 hours, what would I have to multiply that by in order to get there? Well, since our growth rate is 1.5, I want to multiply it by 1.5 1/4 times. So what that looks like is I'm going to multiply by 1.5 to the 1/4 power. Or whenever I have a power that is a fraction, remember we can write it as a root. The denominator is the root, the numerator is the power, so it really is the same thing as 1.5 to the 4th root. So when I look at the answer, I have the two different possibilities here. Those are both showing up here on B and then E. All right, guys, for number 2, we are given the exponential model right here, 20 times 1.5 to the y, where y is the number of years after the number of ants has first been measured, and p is the population of the ants after, or insects after a certain amount of time. One thing that you have to watch out for in this question, it's actually going to come up on number 1. Notice that number 1 says there were 20,000 insects when the colony was first counted. Well, it looks like the initial value is 20, but if you read the question a little more carefully, up here at the top it says the population is in thousands, so all of this is automatically in thousands, which means this is not 20, it's 20,000. So actually, letter A is correct because of the wording of the question. So make sure you read that carefully. Number 2 says part B says 1 decade after the colony was first counted, there were 21,000 insects. Well, if you were to take 1 and put it in here for y, that gives me the answer of 21,000. However, we have to recognize that we're asking for 1 decade, and this is in years. So really, 1 decade is 10 years, so that would be 10. That number would be way too big, much, much bigger than 21,000, so that cannot be right. The growth factor is 1.05 per year. Well, this is the growth factor in an exponential model, so that one is correct. The growth factor per decade is 1.5 times 10. 1.5 times 10, whenever we're working with exponential models, we are multiplying by the growth factor over and over again. So I'm not multiplying to the growth factor, I'm multiplying by the growth factor. So it should be 1.05 times 1.05 times 1.05 over and over again, which would mean that for 10 years it'd be 1.5 to the 10th power, not times 10. So that one can't be right. And then finally, if I want to find the growth factor per month, well, this is the growth factor per year, and 1 month is 1/12 of a year. So I would have to multiply by 1.05, 1/12 of a time, which is exactly what this is doing. So that is the answer for number 2. All right, so for number 4, we're looking at a exponential growth model in graph form, and the question asks the question says the value of a collectible toy is increasing exponentially. The 2 points on the graph show that the toy's initial value and the value 3 weeks afterward. So when we look at the model, we can see that it initially was worth $5, and after 3 weeks, it's worth $10. So we want to figure out the function of the toy's value as a function of weeks after it was purchased. So when we look at here, first of all, we can see the initial value is 5, right? So we know that the function of the value of the toy, so t in terms of weeks, is going to be 5 times something to the w power. Because we know 5 is the initial value, we've got to figure out that growth factor, and it's as a function of time in weeks, so w is going to be the number of times we multiply that growth factor by. So the question becomes, how do we find the growth factor when I have 2 points that are not next to each other? So what I like to do is make a table, the number of weeks and the toy's value. So after 0 weeks, it's worth $5. After 3 weeks, it's worth $10. So the way we want to think about this is how many times would I have to apply the growth factor to get from 0 weeks to 3 weeks? Well, I'd have to apply it 1, 2, 3 times. So really, I'm going to start with 5, and I'm going to apply the growth factor 3 times, and I get the answer of 10 if I were to do that. Now, writing it out like this, we should be able to solve for x. So we take this and we divide by 5, and x times x times x is x to the 3rd power. So x to the 3rd power equals 2. To solve that, we're going to take the cubed root of both of these. So that means x is equal to the cubed root of 2. I don't know what that is off the top of my head, so we're going to use the calculator. The cubed root of 2 is 1.26. We'll round to 1.26. So that means our growth factor is 1.26 for the number of weeks. Okay, for the second part, we're going to look at figure out how to write the expression to represent the toy's value 10 days after purchase. Well, when we start thinking about 10 days after purchase, we've got to figure out how many weeks 10 days is. Well, 10 days is more than 1 week, but less than 2 weeks. So the way that we could represent 10 days in terms of weeks is I could take the number of days, 10, and divide it by 7, the number of days in a week, and that's going to represent our number in terms of weeks. So 10 days divided by 7 is a little bit less than 1.5 weeks, but to make it accurate, we can actually leave this as our exponent because this number right here is the number in terms of weeks. So 10 days is 10/7 weeks. So then we could take our model and we would write 5 times 1.26 to the 10/7 power, because I know 10 days is 10/7 weeks. And then we can use our calculator, and we're going to do 5 times 1.26 to the 10/7 power. So the value after 10 days is $6.96. Number 6 is asking us to look at another graph. So the question says, the graph shows the amount of medicine, M in milligrams, remaining in a patient's body 8 hours after receiving an injection. The amount of the medicine decreases exponentially. Then part A says, by what factor did the medicine decrease in the first hour and a half? This is not asking what is the growth factor. It's not saying what's the growth factor of this per hour. It's literally just asking by what factor did it decrease in the first hour and a half. So to figure that out, the best way to do it is to make a table. Our hours is our input, the medicine is our output. So after 0 hours, it was at 270. After 1.5 hours, it was at 80. So it's asking by what factor, or 270 times what gives me 80. So the way we figure that out is we are going to divide 80 divided by 270. I want it as a decimal, so 8 divided by 27 with a decimal point is 0.2963. 3. I didn't round very far because I want to see what happens when I start rooting and squaring this number. So the way that we know this factor is we divided the amount of medicine that was left after an hour and a half by how much was there at the beginning, and we got this was that factor after an hour and a half. Okay, so then by what growth factor did the medicine decrease in the first half hour? Well, we can actually use the answer to part A to answer this part B, because when I start breaking down what I had to do to get from here to here, if I think about this as 3 half-hour chunks, and so now I'm going to be thinking of the growth factor in half-hour chunks rather than hour chunks, I can say from 270, I had to multiply by 3 half-hour chunks to get to 80, right? But I know what those 3 half-hour chunks are. So 3 half-hour chunks is equal to 0.2963. So this is going to give me all 3 of those half-hour chunks. So if I take the cubed root of that number, going back to the calculator, if I take the cubed root of that previous answer, then I get 0.66666. So that every half-hour chunk is really 2/3. So by what factor did the medicine decrease in the first half hour? Well, it's decreasing by 2/3 every half hour. We know that because we took to the cubed root of what happened in 3.5 hours, because that's essentially multiplying this 3 times to get to 1.5 hours. And so it's 2/3 of itself every half hour. Well, if it's 2/3 of itself every half hour, now part C is asking us to write an equation that would tell us M, given the number of hours, not the number of half hours now, but the number of hours. How could we figure out the equation for that? Well, we know from looking at the graph that the initial value is 270. So the equation is going to start with 270 times some number to the h power. And we can actually use this to help us answer that growth factor. If this is happening every half hour, and I want to figure out every hour, well, I've just got to multiply this by itself twice. So 2/3 squared is going to give me every hour. So that would be 4/9. So its growth factor is 4/9 every hour. So then that is our model for this equation. If we look at number 7, this is going back to the work we did with Khan Academy and asking you to transform a graph k of x to the graph y equals -1/2 k of x plus 1. So what we have to know is what each of those different numbers does to the function k of x. So let's look at each of them individually. So first of all, the negative. I know this copy is a little weird, but the negative. What does the negative, when it's out front of the entire equation, do to a function? Well, that negative reflects it over the x-axis. So I know I should be looking for one of these that says something about reflecting over the x-axis. So A and B both mention that. C and D don't, so it can't be these. Okay? And then that 1/2. That 1/2 is the vertical scale when it's out front, which means that it's either going to be growing or shrinking by that factor. So since it's 1/2, I know it's going to be shrinking, so it's going to be scaled vertically by a factor of 1/2. Well, both of these actually say scale vertically by 1/2, so we're on the right track there. And then finally, inside the parentheses there, the x plus 1, when it's inside the parentheses, that's a horizontal shift. So it's either going to go left or right. And because it's plus 1, when it's inside the parentheses, it's the opposite you'd expect. So it's actually going to go to the left one. So it looks like this says to the right one. So the answer for this one would be